This video is an overview of lesson 9.2, which is about making inferences about two means. These slides are based on slides provided by Pearson to accompany our textbook and then modified by me for our course. This is the second section and two sections from chapter 9 of Essentials of Statistics, 6th edition by Mario Triola, that we will be covering in our class. We've already discussed lesson 9.1, which is about inferences about two proportions. And this lesson will discuss inferences about two means in the case when we have two independent samples. Now, there is another section in your book which deals with inferences about two means when you have dependent samples. Those won't be covered in this class this semester. But of course, you still have access to that textbook, and you're welcome to look into all of those cases that we unfortunately won't have time to cover in this class this semester. Now, we've got a couple of key concepts associated with lesson 9.2. Basically, we're looking at sample data from two independent samples, and we're going to want to do two things. First, we're going to want to test a claim about two population means. We'll do this using the p-value method, the critical value method, and the confidence interval method. And then we'll also want to construct a confidence interval estimate of the difference between two population means. Now, this lesson is broken down into 5 learning outcomes, and those are these. First, we will want to be able to describe the difference between dependent and independent samples and determine whether two given samples are dependent or independent. And that's really important because it determines which statistical analysis tools are appropriate for your two samples. So if we happen to have independent samples, we could use the methods described in lesson 9.2. If we have matched pairs or dependent samples, then we should use the methods described in 9.3. So this first video is actually very short, and it's just describing the difference between those two categories because it's such a critical and important difference when choosing the right statistical tools. Now, our next learning outcome deals with the rationale behind the formulas and procedures used for the p-value method, the critical value method, and the confidence interval method. We discuss all 3 of those and the rationale behind them, which has to do with the sampling distribution of a sample mean, and then how that translates to a situation when you're interested in the distribution of a difference between two sample means. So everything is based on this understanding of the distribution of the difference between two sample means. We're going to cover that and talk about that in this video when we study this learning outcome. We also list and describe the equivalent methods for testing a claim about two sample means in the case when the population standard deviations are not known and not assumed to be equal to each other. We talk about why those are why those are equivalent, and why you always get the same results. And then at the end of the video, we outline that p-value method, and we use it in an example problem to test a claim about two means when we've got sample data collected from two independent samples. In our third learning outcome, we're going on to test a claim about two means. And pretty much the same situation, the population standard deviations are unknown and not assumed to be equal to each other, but this time we use the critical value method. In the fourth learning outcome, we do the same thing again under the same circumstances, but this time we want to construct a confidence interval estimate of the difference between two population means and use the confidence interval method to test our claim. And then in the last video, we describe alternate methods for testing a claim about two population means, or for coming up with that confidence interval estimate of the difference between two population means when those requirements that we discussed previously aren't met. So here we're still dealing with two independent random samples, but if the sample standard deviations, if the population standard deviations are unknown, but they're assumed to be equal to each other, the methods change a little bit. Or if one of the population standard deviations are known and the other one is not, or is known, sorry, and the other one is not, then the method changes a little bit. And lastly, in the most unlikely case of all, it's possible that both population standard deviations are known and the methods change slightly for that case as well. So in learning outcome number 5, we discuss 3 cases and the modifications to our previously described methods that are necessary to handle these other situations which may come up in your data analysis. We don't actually do any of these. We don't work any examples, but I want you to be aware of what's out there and what methods are appropriate and available to you should you ever need them. And that's what this video is about, or that's what that video associated with learning outcome number 5 is about. So that is our overview of lesson 9.2. I'll see you in the next video, to discuss learning outcome number 1, which is about the difference between dependent and independent samples.